Okay, this part of the video is for the tree diagram, the back of the notes. In the first video, in the first side of the notes, we dealt with a table and it had raw data. It didn't have probabilities, it had raw data. What the tree diagram does is help you organize probabilities. So we're not going to have raw data, we're going to have probabilities to organize. So let's read the prompt. A school system compiled the following information from a survey it sent to people who were juniors 10 years earlier. It said from the survey, 85% of the students actually graduated. Of those that graduated, 90% were happy with their current job. Of those who didn't graduate, 60% were happy. Notice how those percentages, those are probabilities. It's not raw numbers, it's probabilities. So we're going to take the tree diagram and organize all this information and then kind of pluck some of that information off depending on what they're asking. So the first thing, you got graduates and you've got did not graduate. You've got happy and not happy. If you let one leg of the tree represent graduates, then there's some graduates who are happy and there's some that are not happy. It would then make sense to label the other leg did not graduate. Guys, did not graduate. And of those, there's some that are happy and some that are not. If I'm being completely honest, this is the most difficult target, the most difficult piece of a target for me to do personally. When you're doing your homework, I have to really sit down and think with you to figure it out myself. It's very confusing. So take really good notes. Everything I put on paper, make sure that you write it down, okay? All right, now let's organize the probabilities. What was the percentage of graduates? It was 85%. So the probability of you getting a graduate is 0.85. 0.85. Well, then if you have an 85% chance of getting a graduate, what's the probability of you not getting a graduate? 15, yeah. But left over is 15%, so 0.15 did not graduate. Next bullet of the information said that of those who graduated, 90% are happy. So that's 0.9, which would mean, 0.1, 10% are not happy. And then the last bullet, of those who didn't graduate, 60% are happy. So the 0.6 would go there. The leftovers, 0.4 here. All right, perfect. All right, now the next thing that you need to do with your tree diagram is put the symbols on the tree diagram that represent the formula. You know, the P and the parentheses, okay? So for graduates, P parentheses will say G for graduate. Use the symbols. For did not graduate, that would be P parentheses, we'll call this DNG. Trust me on this, guys. If we have this tree labeled with all this information, any word problem that we have to figure out becomes a lot easier, okay? All right, so let's now talk about the happy leg of the tree across from graduate. How could you say that person? Could you say it this way, that that is a person that's happy, but we know they graduated? Does that make sense, that leg right here represents a person who was happy, and we know they graduated? That's a condition. The condition is that they graduated. The symbol would look like this. They are happy, and it's a given that they graduated. I'll let that kind of sink in. They are happy, and we know they graduated. So what's the condition? What's given? What do we know had to happen? They graduated. And that came first. That's that 90%. We have to assume that they graduated to apply that 90%. All right, what about the not happy? That would be the probability of, we'll use NH to represent not happy, given that they graduated. All right, and then moving on down, this would be the probability of happy, given that they didn't graduate, B and G. And last, probability of not happy, given that they did not graduate. All right. I taught this first period. and decided to change the notes on you just a little bit, to change the notes to better explain all of this. So on your notes, if I remember right, if you'll look down on your paper, number 8 on the screen is your number 7. Is that right? Number 8 on the screen is your number 7?
Yeah.
See how it's got the if here at the end? If he or she? Okay, so what you don't have is the 7 up here. You don't need all these words, what is the probability of choosing a person, but you do need this. So kind of write this in somewhere above the note, somewhere, wherever you've got some space. For the 7 on the screen, find the probability that they're happy given that the person did not graduate. That symbol would look like this. Happy, H, vertical bar, did not graduate. Would you agree with that interpretation of the phrase? Then look at your chart, look at your tree diagram. Which number is that? Yeah, that's the 0.6, isn't it? See how it has the symbol happy, given, did not graduate? That's what that 0.6 is. All right, so we've got that answer, 0.6, 60%. Now you try the next one, which is your number 7. No, this problem that we just worked, like I said before, is one I added from first period. So you don't have it on your paper. You just need to put it somewhere above the problems that you do have. And the one on the board, number 8 up here, is your number 7. So let's work that one. Try it yourself. Turn it into a symbol. That's your first step. Turn it into P parentheses. Unhappy if graduated. So what symbols are you going to use? NH. Now, oh, good. The word if, it didn't say given, right? But what does it mean when it says if he or she graduated? It means given, doesn't it? Okay, so vertical bar, graduated. Perfect. So then we look back to our tree diagram and we're hoping to see that somewhere. And it's up there, isn't it? It's that 0.1. Not happy, given that they graduated. So 0.1. 0.1, 10%. All right, so those weren't too bad. 60%, 10%. Good question. Number 9 and number 11 are not going to have the if. So we're going to have to talk a little bit about how does it change. So what is the probability that a person from the junior class 10 years ago graduated from high school and is happy? It doesn't say if. Doesn't say if, doesn't say given. So what it means is you don't have a condition. You can't just assume that the person was a graduate or not. You have to explore both options. You have to think about, what's going on here. All right, so the way this one works, I'll just kind of show it to you, and then we'll talk about it. Graduated and happy. That would be the symbols. You agree with that, right? I'm learning target 4. What do you do when there's an and? That's the multiply one. So you're going to multiply the probability of something times the probability of something. All right, this is where it gets tricky. All right, I'm going to keep this on the notes and not put it on the board like I've done in previous classes. The probability of B given A is equal to the probability of A and B divided by the probability of A. That is a definition for given probability. That's on the front of the notes. Now I'm going to insert the letters H and G. And watch what happens. I'm going to just write over top of them. If I put H, G over top of the B and the A, this says G and H, and the A now says G. Now we get a different color. Which of those three probabilities are we trying to find here? The G and H. aren't we? The G and H. We're trying to find this one. So how do you solve this algebraic little expression for what I just circled? You take the probability in the bottom and multiply it over, which means this. To get the answer we're trying to find, we multiply the probability of G times the probability of H given G. Probability of G times the probability of H given G. And it's like, whoa, that's a lot of symbols. So let's go to the tree diagram because that's why we did the tree diagram. It's going to feel better when we look at the tree diagram. All right, we are trying to find the probability of a graduate. We're trying to find the probability of a graduate and they're happy. Well, what's the probability of getting a graduate in the first place?
85%.
85%, the 0.85. All right, once you've established that probability, what's the probability that you get a happy person out of them, out of that group? 90. So it's 0.85 times 0.9.
But don't those other ones cancel? Oh,
So we get 0.85 times 0.9. And the answer is 76.5%. I'm not going to type those in the calculator because we've done enough of percents and decimals and whatnot. You can do that, right?
which one's the one where you have to cancel one cancel? Is that learning target?
Learning target 5 has something where you have to subtract every now and then. I don't know if that's what you're talking about. But
That one.
that
Add the two, like A and B, and subtract the.
Yeah.
probability.
yeah, sometimes you have to subtract.
Yeah. That was three.
Let me pause this for a second. All right. The number 11 for the math teacher who can't count again. There we go. Should have been 10 on mine, but it's your last problem. Okay, it's the last one on your paper. What's the probability that a person from the junior class 10 years ago is unhappy with his or her job? Does this problem tell you to look only at the graduates or only at the did not graduate? It doesn't tell you like number 8 did, like the one we did earlier that said only look at the graduates. This one, let's see if this phrase fits. See if this fits. A person who would be unhappy would be one of these two people. It's a person who graduated that's not happy, or a person who didn't graduate and is not happy. Would you agree with that? Does that feel right to break this question down? It's the person that this is talking about is either a graduate who's unhappy or someone who didn't graduate and they're not happy. Does that feel right? No? Yes? Well, tell me, an unhappy person in this problem, who are they? If I picked up the phone and started calling, who could I get on the phone that is unhappy? I could get a graduate, not happy, right? Or who else could pick up the phone and be unhappy? Someone who didn't graduate. All right, see what that means? Okay, so now it's actually fitting, isn't it? You're feeling that phrase? So the words translate into this. Okay. So the phrase that we just said was that the probability is a graduate and they're not happy, or it's a person that didn't graduate and they're not happy. When you say the word or, remember from Learning Target 5, it's an addition. So the probability of a person that did not graduate, and not happy. So Alex, you were right. You're going to have to add them. So who is a graduate and not happy? Go back to the tree. Graduate, 85%, and not happy, 0.1. You're going to take that 0.85 and that 0.1 and multiply it. 0.85 times 0.1. And then you're going to add that to did not graduate, that was the 0.15, times not happy, 0.4. You're going to do it all in the calculator and hit plus, and it's going to give you 0.145 or 14.5%.